Good morning, everyone. Or good afternoon or good evening, depending upon where you are. Um, Seems just as I was getting started, the bin men are showing up outside to, empty the rubbish bins. So apologies if you hear any noise. Um, I thought following yesterday's lecture, I should spend a little bit of time talking about sorting in Python and the various ways we might try and sort something. So this is why I made this example here. So it's a little bit simpler than the examples in the PW Mini project, but it's still, I have a list of dictionaries here. Right, so I have some dictionaries where every dictionary has at least the two keys of somewhat unoriginally called name and a second key called stuff. So I could create this list of dictionaries. Now, if I just called the sorted method on this list, I get an error, right? Internally Python is trying to use the less than or equal to or less than operation, right? And you can't compare a priori. You can't just say, well, one dictionary is less than another dictionary, right? So this is why if I just call sorted on this list of dictionaries, Python will object. Right? There's no inherent way to order dictionaries. But what I could do is I could tell Python, hey, this is how I want you to view these items when you do your comparison. Right, this is what the key parameter allows me to do. It allows me to supply a function Usually this is specified with a lambda function. Right, the idea of the lambda function right here is that X is going to be one of these dictionaries. Right, so X is going to be one of these dictionaries. I want to extract the name from this dictionary, and then Python will use those names to order the dictionaries. Right? We're saying use the name, use the value of name to sort. And Python knows how to sort these strings, right? Is looking at this string versus this string versus this string versus this string, etc., right? And Python knows how to sort strings. Right, so once again, the key is basically saying, well, here's what I want you to use to sort these items in this list. And it does that. So it sorts these dictionaries by the name, the value associated with the name key in each dictionary. If there is a tie, Python will leave them in the same order they were in the original list. Right? So there's a tie here between this name Fred and this other name Fred. Python leaves them in the order that they were in the original list. If I wanted to, let's copy and paste. If I wanted to, I could tell Python what to do in the case of a tie. Right? If the names are tied, maybe I want them to sort by a secondary key. I could do that by creating a tuple in this lambda function. Right? I'm saying, all right, Python, I want you to look at these dictionaries, and I want you to use this tuple to sort these items. So I want you to look at the name first. If there's a tie in the name, then I want you to look at this other key in this dictionary to resolve the tie. And Python will do that for me, right? You can see the difference between these here, for example, right? That with just using the name, as I said, these two items came out in the order they were in the original list. If I use this tuple to sort items, well, then they come out in the other order, right? Because Fred and Fred are tied, they're the same string. All right, look at this secondary key to try to resolve the tie. And 25 is less than 35. And so that's why this dictionary comes out before this second dictionary right here. And of course, I could sort things in different orders, right? I could say, well, sort this list. I want you to sort them by a different key. Lambda x, look at the value of this stuff key. And then, therefore, the smallest stuff value comes out first. Right? 20, then 25, oh, then another 25, then 29, then 29, 29, 35. And again, the ties, right? I have 25 and 25. Then I have three 29s. If you go back to the original list, right, 29, 29, and 29, if there's no tie-breaking mechanism, Python just keeps them in the order they were in originally in the list. So that's why this one comes out first. This 29, if I look at the three with 29, well, this one will come out first, and then this one, and then this one. All right, this is, again, why the three items with the value 29 for this key. Yeah, if you want to sort in descending order, well, there's some different ways that we could do this type of thing. So if I want to sort in descending order of these values right here, I could say reverse is true. Right, I want you to look at this value here, but I want you to put them in reverse order. right, in descending order. Alternatively, so this is sort in right, descending order by, this by value of stuff. Right, so this is one way that I could get a sort in descending order by the value of stuff. There's another way, which I mentioned yesterday, and we could do it again here. If I want to get descending order by the value of this key, I could tell Python, hey, treat this number as a negative number, right? Instead of looking at 35, I want you to view it as minus 35. And 29, I want it to view it as minus 29. Right, so we still get the value 35, but Python is going to view this during the sort as if this were a value of minus 35. Of course, I can only do this with numbers, floats or ints. Right, I can't do this with strings. Right, so again, this will sort in descending order by value of this key. Right, and there's all sorts of things I could do here, right, depending upon how I create my key. So again, well, let's go back here. I want x of name. So what is this tuple going to do? Sort in increasing order of name, break ties by decreasing order of this stuff key. Right, because again, the minus right here says, oh, I want to treat this number as the negative of this number. So, right, this will be increasing order of name, break ties by decreasing order of stuff. So, again, Fred will come before Mary, Mary will come before Prudence, etc. If I have a tie for the name, then we go to the secondary key right here to resolve the tie. And this says, well, treat this number as the negative of the number. So this 35 is going to be treated as minus 35. And 25 will be treated as minus 25. So minus 35 is less than minus 25. That's why this element here comes out before the other elements. Right, it's because, again, I put the minus right here. If I were to take this and I said reverse is true, Well, basically, this list right here is going to come out completely reversed. Right, so we'll sort by name first in descending order. We break ties for names by looking at the negative right here, but of course you want to keep in mind that we have a reverse here. Right, so it's good to try these things out, right? If I were to again to copy and paste, if I remove the negative right here, you're going to see, a bit of difference, right? These two elements at the end right here reverse their order. Now, a couple of these dictionaries have, they have a third key in them. I can't use that third key unless I do something special. If I try to say, well, use the other key, I'm going to get a key error because not every dictionary has this key. Right, not every dictionary has other as a key. This is why I get an error right here. I can't order by this key, except, so let's talk about this for 1 second. Let's look at a dictionary, one of these dictionaries. So let's copy one of these. Suppose I have this dictionary right here. Right, I could get these values out in the usual fashion. If I try to get a key which doesn't exist, I get a key error. A dictionary has a get method. A dictionary has a get method. If I supply a key, this will retrieve the corresponding value. If I supplied this key here that didn't exist, if I do this in square brackets, I get a key error. If I supply this with the get method, I don't get a key error. I actually get something returned. This returns the special value of none. So the get method, if I look at this help string, d.get question mark, hopefully you could see this, yep. Return the value for key if key is in the dictionary, else it returns the default value. the default value is none. If I want to, I could supply some other default value. Right? Find this key if this exists, otherwise return this default value. d.get name, oops, sorry, d.get name default value. Well, if this key exists, then we return the value associated with that key. If this key didn't exist, I would return this default value. If I wanted to sort by this other, I could use the get method. Assuming, in this case, right, other is a number and other is a number. If I supply a number, oops, I can sort. Right, this is going to use the value of other if it exists, otherwise it's going to assume a value of -1. This is why all of these without this key other are coming out first, because it's assuming a value of -1. Again, if I wanted to, well, I could make my sort more complicated. I could say, well, get the other if there's a tie. If there's a tie, break ties by the value of this key here, this key called stuff. If there's a tie, well, break ties by using the name. Right? Use the key other with a default value -1. If there's a tie, get the value of stuff. If there's a tie, then get the value of name. Break ties in this order. Right, so it's useful to remember that a dictionary has a get method, which won't error if you give it a non-existing key. It will return whatever is the default value. The default value is none, but we could supply a different default value if we wanted to do so. And remembering that there's a get method, a dictionary has a get method, can be useful. Like, I don't necessarily have to initialize a dictionary, to have a set of initial values if I instead use this get method. Because again, I could supply whatever default value I want. This can be a number, an empty list, a dictionary, a string, whatever you want for the default value, right? As long as it makes sense in whatever context you're using it. And of course, well, whenever I'm doing a sort, I could always slip in reverse being true and sort things in reverse order of whatever order is going to be specified here. So it's just useful to try this out. I mean, I could put this little notebook here, into the shared folder, right? And it's just, like I said, it's just useful to spend a little bit of time, trying this sorted method out. And again, in principle, I could sort a list of anything as long as I tell Python how I want to treat them. Because again, dictionaries by definition, there's no way to sort a dictionary. Or sorry, there's no way to sort a collection of dictionaries. This is what I mean here, right? If I say sort Z, there's no inherent way to order these dictionaries. We have to tell Python how we want Python to treat these elements in order to order them. But we could do that kind of thing by specifying a key, a function, which tells Python how we should treat these elements to sort them. And then as well, something like this, we're using Python's inbuilt method. How does Python compare tuples? Right, so if I have a collection of tuples, right, how does Python sort tuples? Well, it sorts by the first value. Sorts by the first value. If there's a tie in the first value in the tuple, it goes to the second value in the tuple to break ties. And so that's what we're using here. So yeah, we could revisit PW exercise 3. I just wanted to talk about sorting in Python. Does anybody know the name of the sorting method which Python uses? And what's the complexity of the sort method in Python? Python's sorting method is called timsort. Because it was named after Tim Peters. Python's sorting method is timsort. simply supply a link here. If I could remember. So yeah, Python's internal sorting method is called timsort. The complexity of sorting a list of n items using timsort is big O of n log n. Sort of worst case. Worst case performance is n log n. Best case, well, is that it's basically that it's essentially already sorted or mostly sorted. So any other questions about this before we go back to the PW Mini project? What in particular was troubling you about question 3 on the PW Mini project? Let's only run the code I need to run. Only running the code that I need to run for question 3, including my group by field method. Right, so question 3, we needed first to join the post code to our scripts data. We have to keep in mind this thing here. Some practices have multiple post codes associated with them. Use the alphabetically first postal code. So as I said here, scripts and practices, we could join those based on the fact that practice in the scripts matches the code in practices. So again, scripts. So this practice key right here gives us a practice code. This code right here is, a practice code. So we want to match the value of practice in scripts with the value of code in practices. However, as I said, we first deal with the repeated values of code in practices. We want the alphabetically first postal code. And yeah, I should be able to explain the coding in the statistics notebook during some office hour, like maybe tomorrow or the next day, or so you want alphabetically first the postal code. So this is the code that the Python code that this was dealing with here, right? I'm going to create a new dictionary. The idea is I want a practice code and a postal code dictionary right here. Dictionary, if I could spell. Right, this is what we're going to generate. I'm going to have a dictionary where the keys are the practice codes. The values are the postal codes. This is what I want to end up with. So I iterate over the collection of practices, right? I iterate over this list of dictionaries. So my practice variable is going to look something like this dictionary. So I just check, right? I want to look at the code. And in particular, I want to look at, the value of this code, right? So the idea is in this practice postal dictionary, I'm going to have a key which will look like A81001 here, and I want a postal code associated with that practice code. So this is what I'm checking. Is this practice code, is this a key in my dictionary? If it is, I want to update the value associated with that practice code. What do I want? Well, I want the alphabetically first postal code. So I take the value which is already stored in this dictionary. I compare it to the postal code, the postcode that this new postcode I have. Right? If this practice code is already in my dictionary, this means I've found one postcode associated with it already. And I just want to take the alphabetically first postal code of this pair. And this is what we're doing here with this minimum. Right, so take the existing postcode you've already stored, compare it to this new postcode that you have, keep the alphabetically first, and update this value accordingly. If I haven't found this practice code already, well, insert that new key value pair into my dictionary. Right, so this will iterate over all of my practices and find one postal code for each practice code. We could compare, so length of practices and length of practice postal. Right, there were 12,020 elements in the practices. There's only 10,843 in practice postal. This is because of the repeated values of code in this practices dictionary. Right, so that's, about 1,400, not quite. Right, so again, this has the alphabetically first postal code associated with each practice. Now, I mentioned this before, this is an alternative way of doing this code with a dictionary comprehension. By using this group by field method that we had written earlier. Right, we do a group by field on our practices on the code. Remember, this group by field gives us a dictionary. The dictionary keys look like this. The values in this dictionary is a list of dictionaries. But again, you could read this code. So again, this is an alternative way of generating this practice postal dictionary. They'll have the same results. I run this and I say length of practice postal alt. I have the same length as practice postal, and practice postal, is this equal to practice postal alt? These are equal as dictionaries, right? So they have the exact same key value pairs. Then, as it said, we could join this practice postal to scripts, right? Here we're making a copy of our scripts dictionary, or sorry, our scripts list, this list of dictionaries. And we iterate over these prescriptions, and we are adding a postcode to each prescription. This is the postcode of the doctor's office that made that prescription. Right, so the script practice, remember, gives us the practice code. We add this as a key value pair into the script dictionary. So again, our new joined data looks something like this. So we have a prescription, and we've added in the postcode for each of these dictionaries. And then we want to do a group by field on postcode now. So we do a group by field on our join the data by postcode. And remember again, well, group by field gives us a dictionary. The key looks like a tuple with one item, namely the postcode. The value is a list of dictionaries. Here we're iterating over that list of dictionaries to sum up the items. items, is 2, items 1, etc. for, a postcode. We're summing up the total number of items prescribed. We're adding a tuple, which is the postcode and the total number of items prescribed in that postcode. And we get tuples that look like this. The last thing we need to do is we want to sort these tuples by postcode. That's sorting this collection of tuples. Python knows how to sort tuples. And I want the first 100. This is what the first 10 look like. And then I can submit my list of 100 items to the grader. What questions or what things were unclear in what I'm doing right here? Right, again, this is all basically manipulation of Python data structures. I want to create a new dictionary. Well, I create this dictionary by iterating over my list of practices. So I create a new dictionary, and then I need to iterate over my scripts to add information to each prescription, which will contain the postcode of the doctor who prescribed that particular drug. Once I have this new information, right, so prescriptions with a postcode of the doctor who prescribed the drug. Now we want to group this information by the postcode and sum up all of the value of items. Will it be common to use item when dealing with a dictionary? The .items method, yes. It's .items, note the S. Right, if I say, well, for K, V, and Z.items on my example, right, print K and V, oh, sorry, this is a dictionary, of course. Oh, sorry, a list. And D. Sorry, in my dictionary D. All right, so here's my, right, this was my dictionary D. Right, this for X and D dot items, print X. For if I iterate over, if I say X in D dot items, this gives me a tuple, a key value pair. This right here is doing tuple unpacking. Namely, K gets the first element in this tuple, and V gets the second element in this tuple. So if I iterate over, if I just print out V, well, I get the values. If I were to print K, well, I get the keys. Right, so I can iterate in this fashion, and I get tuples. It's typically a little more common to iterate, over, right? I do the kind of tuple unpacking right here because usually I want one or the other or sometimes both. So yes, it's very, very common to use the .items method, say when iterating over a dictionary. Remember as well, a dictionary has a keys method. .keys will iterate over the keys. A dictionary also has a values method. And there's nothing special about K or V. I could use key right here or whatever variable name you want. Right, for ZZZZ. Right, this is just a variable name. I tend to use K and V or, explicitly maybe write out key and value. All right, question 2. Yeah, I know some people asking about question 2. I think there's a little confusion. Yeah, so we find the unique name. So we want to find the most common item. Now, maybe this could have been described a bit better, but the idea here is, remember, our groups are going to be again, groups is a dictionary. I want to sum up the value of items in all of these dictionaries. So the idea, again, all right, so maybe I wrote the code, so I'm saying, so groups is for I think I might have erased this. Oh, here, sorry. This part here. So, all right, so once again, I'm finding the unique names of drugs. Now, I want to create a collection of prescriptions. So groups, this is going to be, right, this is a dictionary. The key is name of the drug. Value is a list of prescriptions for that drug. Let me right, so this is going to be a dictionary that I'm creating. The key is the name of a drug. The value is going to be a list of prescriptions for that drug. Right, so I start out with a dictionary where I have The keys are the names of the drugs, and I initialize those with an empty list. Now I iterate over my prescriptions, and what do? I find the name of the drug for that prescription, and I'm just going to append that prescription to this list associated with that drug name. Right, so as I said, all I'm trying to do is I'm trying to create this dictionary. The key is the name of a drug, the value is the list of prescriptions for that drug. So the key I want is the BNF name for this prescription. Remember scripts remember this is what our scripts list looks like. So script right here is going to be one of these dictionaries. I find the BNF name out of that dictionary, and that's the name of the drug that I want. This is going to be one of these keys in this group's dictionary. I want to take that list associated with that drug name and append this prescription to that list. And when I'm done, well, again, this is an example of one of my lists. So for this drug, there's this list of prescriptions associated with that drug, right? So all these BNF names share this same drug. Right, so this code was just to construct this group's dictionary. And then now I have this group's dictionary. Well, again, I want to sum up for this drug. I want to sum up this number and this number and this number and this number. Construct our groups, we should sum up the items in each group and find the BNF name with the largest sum. And we could do that kind of thing with for one drug name. I could, again, do a list comprehension to extract the number of items from that dictionary and do a sum. I could repeat this kind of thing for every name in my dictionary keys. So again, here's an example where I'm iterating over the keys of the dictionary. I could easily have written this as a comprehension over groups.items. So I could get this list of tuples. I want the item that has, I want the tuple that has the largest sum. And so again, I could use a max and I could specify a key, right? I want to maximize where I consider the second value in the tuple. And this will give me my item that has been prescribed the most. So David, I hope that's a helpful explanation. We're out of time for today. So yeah, I could look into perhaps tomorrow. We could look at the coding in the statistics notebook, for example. So I will wish you all a pleasant day, and I will see you all tomorrow.